this improvement in affordability has been the adoption of computation across sector after sector. There's been this virtuous cycle of more and more people doing more computation and therefore driving prices down and the technology improving, and that continues to the point where today we have computers in our pockets, we have them on our wrists, we have a number of them in our cars, numbers of them in our tractors, in our rail cars, on the tracks, you name it. Things are becoming instrumented today, and what all these do is they let us see what all these devices and people and what our world, what our businesses are actually doing. They give us this very high resolution imagery of ourselves that we can use to improve. It's very hard to optimize something if you don't know how it's working. You need to be able to observe it first. And data gives us that capability to observe things at greater and greater degrees of detail. The more devices we have, and the more data we can collect from these devices. So Mark Andreessen is famous for saying a year or so ago in a blog article that software is eating the world. And in that he talks about that the industries that are growing the most are adopting computation heavily. And in fact, nearly every industry is adopting it, and the players within each industry that are adopting technologies are those that are succeeding more than their competitors. So it really looks that almost every industry is becoming a data-informed industry. Industries that you wouldn't expect to be using data. At least I wouldn't initially. Retailers, maybe you'd guess that retailers would be. Tractor companies, I'm not sure would have guessed. Farmers, I'm not sure would have guessed. But these are all becoming, at least to some degree, high-tech industries. They're all generating lots of data, and the folks who are using it best are the people who are succeeding. So with the Moore's Law, I was saying the prediction is that we'll be able to store and process more data in the future. Here, I think the thing we can draw is that in the future, we can't afford not to store and process more data if we want to be successful. That's an imperative for institutions, that they start figuring out how to harness it. So we have some hardware, we have a problem, we have some data, we need some software to begin to address it. And first we need to figure out how we're going to create that software. In the past couple of decades, we've seen the emergence of a new model of software development in open source. We've seen again and again when there's an open source version of a sort of platform basic technology, that it pretty soon becomes the commodity, the default that everyone uses, and that the industry standardizes on. We've seen that with Linux as an operating system. I think it's easy to argue it's the most successful operating system in the world right now, the most deployed operating system, from mobile devices to servers. Android, built on Linux, is becoming the most prevalent mobile operating system built on open source. The Apache web server, famous example serves more web pages than any other server. It's run on more sites than any other server. So again and again, we've seen this phenomenon where open source wins the battle. When there's an open source alternative, it tends to be preferred by users. I've seen this personally with Lucene. I originally wrote Lucene in '97, as I mentioned, when I got started with Java. Made it open source in 2000. I was thinking I was going to build a business around it. I decided not to do that. There were other search vendors at the time who were established, selling to enterprises, had sales forces, had big manuals, had support staff, had all these things that I didn't have. And maybe they were technologically inferior, but they had a lot of the other things that were required to be a successful business that I both didn't have and wasn't eager to build, and it wasn't clear that I could have beaten them. But by pushing Lucene out as open source, I think it's exceeded any of those companies that were around in those days, and perhaps any others since. It has become the default standard platform for search software. And I like to think that's because of its technical excellence, but I don't think that's wholly the case. I think it's the open source has more to do with Lucene's success than the fact that it needs to be technically adequate in order to compete, and then it's been improved by the community as more and more people adopt it. Another one of these virtuous cycles is the way that open source improves. And if you step back and think a little bit about this, it makes sense as consumers of software, to users, open source, the attraction of it. There's the free as in beer part is obviously attractive, but that may come with some risks, and people may worry about the total cost, or they need to buy support. There may be mitigating factors there, but I think there's other things that actually sort of seal the deal. If you think about building a business on top of some technology, so technology at the center of your business, if you license that technology from a vendor under terms that need to be renegotiated regularly, then effectively you're building your business at the mercy, at the pleasure of someone else, and the terms of that contract which are up for renegotiation. And that doesn't always work out well. As your business grows, the amount you might pay for that software might grow, and it could actually come to threaten the vitality of your business. People are uncomfortable with that. As you decide you might want to pivot and maybe install your software in other places, then that's going to constrain you in various ways, the contracts you have around that proprietary software. Whereas with open source, there are none of these strings. If you want to use it more, you can generally just use it more. The price isn't going to change. If you want to deploy it in a different way, you're not going to have to pay a different rate. And so in general, there's less fear of adopting it because there's less risk that it could expose your business to future problems. Other advantages I think that it has are that simply that people can see the source. When you're developing against open source, developers frequently have problems with software, and when they can dive right in and look and understand why it's failing, then they can very easily diagnose problems. And so they prefer it for that reason as well. So whatever reasons you believe, I believe it's a fact that open source again and again wins. So the prediction I think we can make from this is that a future platform for data needs to be based on open source. Needs to be an open source software platform. So great suspense now. What software might we use for, what open source software might we use for data? So I made Lucene an open source project in 2000, as I mentioned. Started a consulting practice around Lucene, working for different firms every couple of months, helping, improving Lucene and helping folks to use it better. And someone approached me around 2002 or so, sort of daring me as much as anything to try to use Lucene to build an open source web search engine. So it's a sort of Google-like thing where it was crawling, analyzing the crawled content, indexing it, and then producing the end search engine. I worked on web search before this for several years at Excite, built a web search engine, so I was familiar with the problem, and I thought it'd be fun to try to do it as open source. The web had grown, at least tenfold since I'd been involved in web search, and was still growing rapidly. We knew that whatever we did had to be very scalable, that you couldn't take one computer and put the whole web on it, that it was going to take a bunch of computers, 10, 100, 1,000, something like that. You needed a distributed system. So we designed some ways to do this in a distributed manner. This was me and a fellow named Mike Caffarella mostly working on it at this point. Mike was a grad student at University of Washington. And we got it up and running in a couple of years. And by 03 or so, we could run on 5 machines. We could crawl, a few 100 million web pages in a few days, and keeping all 5 machines busy pretty much all the time. But it was a full-time job to operate this thing. I was either spending the week running a crawl or spending the week developing the software. I couldn't do both in the same week, really, because you had to watch for when one process completed and move its output over somewhere else to be somebody else's input, and then watch for these other things and check the logs to make sure there hadn't been errors. And it was what I call operationally onerous. So around that time, 03, 04, Google published 2 papers. First, they published a paper about their distributed file system, the Google File System, GFS, which was a way of taking a bunch of standard PCs with a bunch of hard drives, which was the kind of hardware we had, maybe 4 drives on each machine, spreading the data across all the machines, but making it look like one continuous file system, and doing so in such a way that if any time any hard drive or any machine failed, you wouldn't lose any data. In fact, you wouldn't even have any downtime. You didn't even need to worry. You just lost a little bit of your capacity, both your sort of I/O capacity as well as your storage capacity. So things get a little slower, a little smaller, but other than that, you could shoot machines at will. And this seemed like a really nice model. And then a year later, they published a paper about their MapReduce system for doing processing on top of such a file system, and it had a very similar flavor in that you could run a computation over a data set that was stored across a bunch of machines. And if at any time a machine failed or a drive failed, the computation would continue. It would maybe go a little slower, maybe get a minor setback, be a hiccup, but the failure handling was all automated, as well as the sequencing of processing and the movements of outputs to input. All this sort of stuff was automated as part of a framework. And so, a light bulb went off for me. I was like, wow, it's actually the same algorithms that we were using in Nutch already. We were already doing MapReduce. We weren't calling it that, but we were doing it by hand. And here we could automate it in a framework with reliability. Was a great advance. So Mike and I spent the next year or so, 2004, 2005, implementing a distributed file system. We called it NDFS originally, for the Nutch distributed file system, and a MapReduce engine that ran on top of that. And then we moved the existing Nutch algorithms on top of this, wrote them as MapReduce programs. That only took a month or so, and we were up and running. And now we could run on 20 machines, which is as many as I could scrounge at the time, and let it run for a week and do something else at the same time. And it was really a huge step, but it was still pretty rough going. There were lots of little bugs here and there, and you'd fix one, and it was whack-a-mole. You'd fix one little thing, and another thing would come up. And the tail for fixing these seemed incredibly long. I didn't have much confidence that I'd have something that was really stable enough for somebody who wasn't a developer of it to use and have confidence in, or that it would run well on 100 or 1,000 nodes. I couldn't in good faith tell somebody that at this point. And I also was worried that at the rate it was improving, we wouldn't get there for a decade. And I thought this technology would really be useful to a lot of people. And I was just thinking of people building search engines. That was as far as my horizons were. It turned out it was useful to people doing all kinds of other things. So around the time Yahoo approached me, and they said that they were having a problem with their existing computing infrastructure, and they saw this as the best starting point for their efforts, and they wanted to start doing open source. So I went to work in January of 2006 at Yahoo, and we split those two parts of Nutch out of the search project and into a new project that just had the file system and the MapReduce engine, and christened it Hadoop in January of 06. Over the next year or so, together with this team of engineers at Yahoo, we really ironed out all those bugs. We got it to scale to first 100 nodes, and then 1,000 nodes, and then 2,000 nodes, and be pretty rock solid, and to perform pretty well. I still had some major shortcomings. There was no security. Anybody could read and delete any file they wanted. There was no logging into the system effectively. There were single points of failure in the system. If you lost the name node, then the whole thing would go down and nothing would run. It didn't happen very often. In practice, Yahoo suffered, I think, next to no downtime because of name node failures. But it's still not a very comfortable position to know that if especially if you're trying to use it in a production setting, then that was a little bit of a smudge on our reputation. But gradually, all these things got addressed. Security was added on top. The single point of failure in the name node was removed. And we've seen this again and again, that people see deficiencies in Hadoop and they improve it. The performance has been doubled several times over since those early days. Recently, we've added encryption to the file system, and it continues. The MapReduce engine itself has been refactored into a general purpose scheduler, as well as the MapReduce application itself is now user level code on top of this general purpose scheduler called Yarn. So it keeps improving. So the prediction I think we can make from this history, from these facts, is simply that Hadoop will keep improving. That it's effectively become a kernel for distributed computing. That is this foundation for all kinds of things. So what I find tremendously exciting about this, though, is all that's happened on top of Hadoop. We've got this kernel, but a kernel really depends on the tools and applications that build on it. And we've seen phenomenal things added here already, and I expect this to continue as well. So initially we had just MapReduce, batch programming for folks who were Java programmers who were happy to think in terms of map functions and reduce functions. Now, maybe the people in this room would be happy with that because you're Java guys and gals. But a lot of people in the world aren't Java programmers and don't fluently think in terms of map and reduce functions, and also don't necessarily want to do everything as a batch job. So initially we saw a step away from requiring Java programming. We saw that the PIG system developed at Yahoo, so a higher level scripting language that let people get away from Java and write these PIG scripts that were implemented on the back by MapReduce jobs, but people didn't have to actually write the MapReduce jobs. Facebook started using Hadoop, became frustrated with writing MapReduce by hand, and came up with a system called Hive to translate SQL queries into MapReduce jobs. And now you've got millions of people in the world who know SQL, and they could all now have access to this. And so this is really, initially just having MapReduce alone permitted people to do things they couldn't really do before, to perform computations easily, affordably, reliably, scalably, in ways that you had no tools at all before. But now bringing that power to more and more people. Then we started to see a move away from strictly batch processing with MapReduce as a backend. We saw HBase. Google published a paper about a system they have called Bigtable that is an online key value store, a NoSQL type database. And that was re-implemented in the Hadoop space as HBase. Now you have something that's not batch at all. It's very much an online system, real-time, random access to value stored under keys, and integrated into the Hadoop system so that you can run MapReduce jobs over H-based tables, uses the same security models, builds on top of HDFS, so shares the storage system. A nice complement to the batch processing. Then we've seen more recently things like Impala, which is a much more optimized SQL engine than Hive has, so not based on MapReduce. A dedicated set of daemons running on the cluster to implement interactive SQL queries. And we've seen interactive search. Lucene, which in the intervening years has been delivered as a server inside of Solar, and then Solar has been generalized to run distributed, so-called Solar Cloud, so that you can scale to much larger collections, much larger query throughputs. And then Solar Cloud has been ported now to live on top of HDFS, to live within the Hadoop ecosystem. And so we've got another interactive system. Besides Impala, we have search now. So again and again, we see new kinds of functionality added to this common platform. And I think that the moral here, the prediction we can make is this is going to continue, and we see it continuing. We see systems like Storm and Spark, and you can pick your favorite. There's probably 10 active new projects today providing new kinds of functionality that live on top of this Hadoop kernel, forming this Hadoop ecosystem. And what we've really seen is Hadoop has come to dominate this space. When I first saw these papers from Google, I thought, well, lots of people are going to see this and realize this is a better way of doing things, to use commodity hardware instead of exotic, fancy enterprise hardware, and build the reliability into the software to build a single storage system, and then have general purpose processing on top of that. So you can have one copy of the data and not have to move it between systems, but you move the processing to where the data lives. So rather than having a storage system that's on a separate bus from the processing system, as is oftentimes done in enterprise database systems, instead you have processors and disks next to each other, and you send the program out to where the data lives and run it there locally. So different style of building systems that scales much better. Much more affordably, and also technically will scale better. And the way that we handle failures. So I expected other people to hop on this bandwagon. I expected Microsoft to have its own, and they did to some degree, but they've more or less abandoned it, at least in public. They may use it some internally. IBM, et cetera, I thought would come up with their own sorts of solutions in this space. Instead, what's happened is all of these folks have standardized on Hadoop as their big data strategy. We see it across the computing industry, that this has become the standard. And so I think this speaks for we now have this sort of common trend, I think, in the industry, where more and more kinds of workloads can move to this common data repository, this common platform, and you can start to see the older paradigm diminish, where we had silos that were running different applications that were built over a long time, very highly engineered for one particular purpose, not very flexible, and difficult to move data between, instead moving into this common platform where you can have more agility and flexibility, bring different tools to bear, make experiments, and evolve your applications more rapidly. It really seems to be where things are going. That these silos are being torn down, and what we call the enterprise data hub is becoming the common platform for data. So I think that's the prediction I'm going to make from this observation is that that's where we're headed. The new default for data systems is now the Hadoop platform. It's no longer the relational database or the data warehouse or the SAN or whatever that had been in the past couple of decades, the enterprise data platform. This is becoming this will become the new normal for data systems, with more kinds of workloads supported on it over time. So how far can we take this? I think the sky is the limit here. There aren't real hard kinds of functionality you can't do on this platform. Google has demonstrated that they can build very scalable distributed transaction systems. I have a paper called Spanner, where they have a multi-data center database. They can lose data centers and continue, not lose any transactions. Quite an impressive piece of work. People didn't really think it was possible. I sort of think was a common feeling to build distributed transactions that were reliable at that kind of scale. And now we have an existence proof that you can. And I think it's inevitable before we're going to start seeing systems like this in the Hadoop ecosystem. So don't get me wrong with this slide. Don't misinterpret it. I'm not saying that you can do OLTP on Hadoop today, but I'm saying in the next 5 years, people will be doing OLTP on Hadoop. Even that kind of functionality will be available here. That I don't think there's anything that's out of scope. My colleague Amar Awadali uses a metaphor here of the smartphone. That a smartphone has a lot of different functions. It's a general purpose device. It's a phone. It's a satellite navigation system. It's a sports tracker. It's a camera. It's all these things. Now, it's not necessarily the very best thing you can buy for each of those purposes. If you want the best camera, you probably get an SLR, 35 millimeter SLR, or maybe something even better than that. But most people take most of their pictures today with a smartphone. And so I think that's where we see Hadoop, the space that Hadoop is coming to occupy. There will be applications, there will be uses where people will have purpose-built technologies where they can optimize and do them outside of Hadoop. But I think for the most people's primary data repository and most of the processing they do on their data will in the future move to Hadoop. I believe that's the prediction that we can make from this. That is the trend that things are pointing towards. As it supports more and more functionality, more efficiently and more economically than any other platform, there's no reason you wouldn't move more functionality to this. So I started out saying I couldn't predict the future. Now I've given a rather grand vision of this enterprise data hub. Hopefully you're convinced by this triangulation of trends that we are moving into this world where we have this single center for our data in the enterprise data hub. We are in a revolution, in a fundamental change in the way we build data systems, and revolutions are kind of frightening times. It's hard to know what the safe path to the new stability is, and Hadoop is that safe path. It is the route that we will be taking to the future with our data. So that is all I prepared. Happy to rhapsodize more on big data stuff like this, or if you want to talk about Lucene, Avro, more Hadoop stuff, Java, Apache, open source, any of those things I'm happy to converse about as well. So I'll take questions. Yeah.
How do you see Docker and some of the things about Docker fitting into
The question is, how do I see Docker and Mesos and things like that fitting into the Hadoop ecosystem? I think the resource scheduling is an area that's evolving quickly. So Yarn is now the thing that's part of Hadoop, but Yarn doesn't necessarily satisfy all needs. I think we're going to see some integrations where Docker can live within Yarn. People can use Yarn to deploy Docker apps. That's one immediate direction. But like I said, I can't see the future, can't see all permutations. The strength, I think, of this platform is that it's architected as a set of loosely coupled open source projects, all of which are changing, and moreover, which new ones are showing up all the time. And so it supports evolution very naturally. There's no central control that can say, no, that threatens my business model. You can't do that. And instead, I think we can see the platform evolve. If a new way of doing things comes along that's better and that actually works, then people will adopt it. So if Mesos gets to the point that it's a better way of doing resource allocation, and then the other tools will begin to adapt to use it, and it can assume more of that role. So I don't know if and when that will happen, but I think we've got an architecture where that can happen when it's appropriate. Not a great answer. Yeah?
In my opinion, Java is evolving much slower than a lot of other languages like Ruby and Scala and Clojure and whatever out there. Do you eventually see it fading from the marketplace and being replaced by other languages?
Do I see Java fading from the marketplace? No, not too quickly. I think actually Java started to evolve reasonably quickly in the last few years. But moreover, I'm not convinced that evolution of a programming language is a good thing. I think in many ways, even like as with APIs, there's a certain point at which stability is more important than evolution. That it's a known thing, it does something well. Maybe you can make it do that, perform that function better. But changing APIs is oftentimes worse than leaving them alone, even when you think you're improving them. And I think same with programming languages. You've got a lot of people who are invested in that skill. Yeah, it's not ideal for doing everything, but there's pretty well-known workarounds to most of the deficiencies in Java. And some of them are being addressed. My initial reason for liking Java is still the reason I like it, is that it's a good compromise between performance and the ability to develop software that is reasonably reliable without too much pain. And I think another thing that comes out of it, or corollary of that, is the rich set of libraries that you have in Java, which I think is mostly unmatched in other languages. But we'll see. I mean, something better could come along. I haven't seen anything yet that overwhelms me that it does a better job at that compromise of still having decent performance and permitting the development of a large base of libraries that can be used well together. Yeah.
As a semiconductor vendor, where do you see opportunities and things to improve the Hadoop performance?
So as a semiconductor
Vendor, where do we see opportunities for improving Hadoop performance? Like what areas?
Where are the opportunities for improving performance of Hadoop? So, I mean, we have a partner as a semiconductor vendor in Intel at Cloudera, and one of the things they tell us is that we should be prepared for is the increase in size and speed of memory. That we ought to think more and more about data structures that live in memory and machines with large amounts of memory, which I think is a neat direction. A lot of the systems that I've been involved in building in my career are designed very much around the characteristics of hard drives and the seek versus transfer trade-offs. And those are somewhat different with SSDs and radically different with RAM. So I think that's going to be a big change. Whether we'll see more hardware support for, we see hardware support already for encryption, decryption, for checksumming that we're able to take advantage of. And perhaps there'll be more things like that where you add purpose-specific instructions. It's a little tricky to figure out how to do that for a general purpose platform, to find those things that are so common they deserve silicon. And I'm not close enough to that to make any predictions there.
How about from scheduling perspective, source allocation, scheduling?
From scheduling of
Sources.
potentially. I mean, again, it's not my area of expertise. Do you have any predictions?
No, I'm just I work for LSI slash Avago slash Intel now. So I have dealt with the PCI-based flashcards, which accelerate how do you performance of code. I was thinking about there's you see how the Windows coming in, which will to improve performance of that.
I think
Apart from memory, of course.
memory is a big one. Bigger networks, faster network switches can play a big function. If a lot of the most affordable switches are topped out at a certain number of ports, and if you can get more ports, you can get more cheap processors that can quickly communicate. So I think that's an interesting area, is networking hardware. But I'm overall just still incredibly pleased at what we've seen. I mean, and it's in the lifetime of Hadoop, we've seen a phenomenal improvement in hardware performance and networking performance and hard drive size and memory size, every aspect in just the last few years. The nodes that people running Hadoop on look very different today than they did 6 or 8 years ago. So it's the ironic thing, it seems to me, with hardware, which you're kind of hinting at here, I think, is the reason that Hadoop was originally architected the way it is that it was building on this commodity that we had in desktop PC hardware. So desktop PCs had sold huge numbers, and they developed this inexpensive processors and motherboards and drives and so on for that, which we were able to then ride that cheap hardware wave. Now Hadoop is itself driving the cheap hardware wave, which means you can actually start to customize it for this application. And I'm not a hardware guy. I don't know where that's going to go, but it changes the dynamic a lot. Oh, sure.
Your discussion there made me think a little bit of Spark RDDs. Any thoughts about potential bringing that into stuff like MapReduce?
Well, I think for most people, Spark RDDs are going to replace their uses of MapReduce. I think we're seeing more and more people, fewer and fewer people are writing MapReduce programs, and more are writing Spark. And engines that emitted MapReduce jobs on the back end are being ported. Pig and Hive and Crunch and all these things. People are working to get those to emit Spark on the back end so they can take advantage of RDDs. So I think Spark is kind of the new MapReduce. I think it's becoming the new default runtime and API for writing distributed batch and online algorithms for the ecosystem. So I very much embrace it. Again, it's sort of with this talking about the evolution. MapReduce isn't going to go away. You don't want to remove an API that people have used and that works, and it'll continue to serve people well for a long time. But for people starting afresh, Spark is probably the better place to build things. It's probably the future API for the platform, our primary API instead of MapReduce. Yeah.
Do you see Avro getting any more love than it's been getting the last few years?
Do I see Avro getting any more love? Avro gets used a lot. I think it is, it has slowly become sort of the default primary data format for people within the ecosystem. I talk to people all the time who say, oh yeah, our data is in Avro predominantly. There's some people who say they're using, gzip CSV files, and some people are using sequence files. But I say that's the minority. I haven't done, my informal polling. Maybe people are just trying to make me happy as Avro's daddy. But I get the sense that it's adopted a lot. it doesn't seem to get a lot of contributions. The project is pretty darn slow at moving. And you know, optimistically, I like to think that's because it mostly does what people want and does it pretty well. That there aren't showstopper problems, it doesn't need to be rewritten, it just kind of works. That's my hope, is what the issue there is. Because I do hear about a lot of people using it over and over. I talk to people who have never submitted a bug report and they say, oh yeah, all our data's in Avro. So that's sort of a definition of something that works. But maybe your experience is different.
Well, no, I was just wondering if it would make the jump outside the Hadoop system.
Oh, I mean, it's really designed to live within the Hadoop system. There's a lot of things that Avro does that I'm not sure are of interest to people outside of the Hadoop ecosystem. But I think it is the most interoperable format within the different components of the Hadoop ecosystem. It's kind of the only interoperable format besides CSV and maybe sequence file, both of which are very weakly typed and not very good interchange formats. So I think it's succeeding as designed.
I love it.
So you don't think you get messaging middleware happening?
Oh, for RPC sort of things?
RPC compared to like a cross language.
So yeah, I'd also hoped we could have it used for RPC, and there were various political issues around that. And it's really, I think, it's been most successful as a data format. So as an RPC system, I don't know what it is about RPC systems. They seem to be really hard to get anybody to agree on and invest in. And there just hasn't been nobody's been willing to make the investment to take it to be the level of being a really interoperable RPC system. I think you could definitely build it. I think it's got the right. And there are a lot of people who use Avro RPC. There are some major technology companies I know of who are sending millions of Avro RPCs around a day internally, probably triggered by events that have happened in this room during our meeting. So it is definitely used, but that hasn't been its primary purpose. And I don't, you've got enough other things out there and people building home-built RPCs over and over again. Hadoop has its. Everybody seems to have theirs. And that was my hope, is that we could get a groundswell around RPC for Avro as well. Hasn't happened yet, and I can't do that alone. So if somebody wants to jump on and drive it, I'll be right there behind him. Yeah.
I'd like to hear what you say about machine learning. The reason I ask is one of the hardest problems with machine learning is scale and parallel processing. There's a very limited scope for parallel processing. And I know that Mahmoud is doing something in parallelizing batch propagation. How much of that is getting interest in your community?
I think there's a fair amount of interest. There's definitely people doing, building machine learning algorithms and deploying them in production. It's not as a company, Cloudera doesn't see that many of our customers for whom that's the driving need for their adoption of Hadoop. So we're not focused intently on it. We're interested. We're watching all the different. We support Mahout as a product. We've got some folks in our data science group who've written this thing, Oryx. We've got people who are playing with Spark ML. So there's a lot of different efforts going on. And I think from a company perspective, we're sort of in a wait and see. See where people tend to, use what finds a lot of traction. And right now, it doesn't feel like any of them have a huge amount of traction. And nor are we seeing, even if it weren't, if we felt like there were a lot of demand for something, then we might invest a lot of resources in building something to respond for that demand. But we're not seeing that. As I think the short answer. The other thing I sort of feel about machine learning is that it seems like every time somebody uses one of these systems, they end up copying the code and customizing it. They don't use the libraries as is much, that they tweak the algorithms for their application, which to me indicates that the abstractions are not quite there yet to have a really reusable library. And I don't know whether that means it's impossible to do for machine learning, that you always end up having to tweak things, or whether you just need a lower level toolkit sort of for machine learning rather than higher level algorithms. I'm not sure. And it's also not my area of expertise, so I don't, I'm watching it from a distance.
What are the ways that
A really popular one is these days is this data warehouse offload. People are paying Teradata an arm and a leg for their data warehouse, and they find that 90% of the work they're doing in Teradata they can do either with MapReduce or with Spark or with Impala much more efficiently, much cheaper, and so they're moving to that. We see, new companies start. So that's sort of offload for existing big companies is a huge thing for us. And so getting all the right features so that works well, trying to enhance Impala so it supports all the queries that they're performing currently, adding in the right security things so that they can comply with regulatory stuff, adding the right, making it easy to operate so they can pull it in and run it as easily as they were running Teradata and monitor their progress of their jobs and all that kind of stuff. That's sort of the bread and butter of what Cloudera ends up doing these days a lot. It's not thrilling in a lot of ways, but it is gradually changing a lot of these companies. They are moving to a different style of work. They start off with a sort of cost-cutting measure, and the cost-cutting often turns out to not just be cost-cutting, but it allows them to increase the amount of data that they have available by like an order of magnitude, at the same time as cut costs, so that their data warehouse becomes much more useful to them. They free up workload on their Teradata, which they maybe they don't get rid of altogether, so they can do more there too. And then they start discovering other things they can do. They start running little machine learning experiments. They start moving other kinds of analytics and reporting jobs, and developing new applications entirely from the start on this platform. But that offload is a big initial case for us. It's why we've built tools like Impala and worked so much on security to support those kinds of things. Yeah.
Yeah, talking about security, you have mentioned a little bit about security in the beginning of the class. So I have a question, two different aspects of security. One is how do you secure access to Hadoop at runtime, as well as how to secure the data at rest in Hadoop. So what are the approaches that industry has been taking in that aspect?
So to control access, that we use Kerberos. So you authenticate with Kerberos, and you have to have tokens that are passed around that authenticate you to all the services. So when you're running a job under Yarn, the job runs as you. So within the host, we depend on Unix securities. We run them we use C groups. So they're run in a separate. It's not quite a VM within Linux. I don't know if you're familiar with C groups. So you get a different root. You can sort of isolate processes to some degree and limit the number of resources they use. So that gives you some. You're still potentially. You're still definitely running user code on a shared service. So there is risk. People if there's ways that people can escalate to root, then that's a hazard in this environment when you're doing things like MapReduce, where you're running user code in the cluster. As far as data at rest, encryption is not. It depends on what you mean by. Encryption is coming out in the base Hadoop product. It's currently available as an add-on in several different ways, so you can encrypt all your data at rest. And you have a separate key server so that even so the file system administrators can't read the encrypted data, So you separate the file system administration from the key administration. So it's a good system for securing data at rest. Trying to think of this. All the traffic on the wire is encrypted between all the services. Everything will run over HTTPS. I think that mostly covers it. What's tricky, I think where we keep continuing to work on security is, so you've got security in the file system where you can, so we talked about authentication and encryption, but authorization is I think the thing where things need to evolve the most and will continue to evolve for a long time. So you can have permissions, sort of Linux-style file permissions, which is fine, but if you're dealing with something like HBase or even files represent columns in Impala, you want people to maybe be able to read certain columns but not others. So you want to do column-wise access rather than file-level access. So the Sentry project adds that as a layer. So you can do, and that works with Impala and with Hive and with Search and probably with a few other things. HBase has added cell-level security, so not just row and column, but cell-level ACLs. The file system has added ACLs. We have in Clutter and Navigator the ability to see the history of where something has come from, the lineage of a data set. So that you can look and you can say, oh, this column came from this column, which came from that over there and was collected in this way over here, and walk back the full history, and that's collected passively by the cluster as you're processing. You don't have to build that in. But I think related to that is this notion of automating the visibility of things as it travels through as well.
So would you say the integration of Kerberos with Hadoop is mature enough for?
Oh yeah, the Kerberos stuff is definitely mature. Yeah, and it works with Active Directory, so you can if you're a Microsoft shop for your users, you can use that same user database in the Hadoop cluster.
So are you aware of any like Jasper report that will allow ad hoc versions of Hadoop data?
I don't know enough about that. Probably. Is there somebody else who wants to tackle that question? Anybody here?
Any kind of front end, like Jasper reports and front end onto an SQL database?
I mean, we're seeing more and more traditional SQL tools ported to run on top of Impala and Hive. So Tableau, for example, we've got a lot of customers that have been using Tableau for years and against other SQL backends, and now they can use Tableau against Hadoop. So,
natively, or is it importing into SQL?
well, Impala is an SQL engine, so I know what you mean by querying natively. It's emitting SQL queries that are being run against Impala, and done so interactively. And there's demos of that you can find on YouTube and stuff. It works really well. Yeah.
So I'm not sure, but I heard that Hadoop is very good when you deal with raw data, but compared to full relational database, it's better, faster when you query. So is this statement true?
So the question is it true that Hadoop's better with raw data, but if you have structured data, that a relational database is faster?
Maybe Hadoop shift the primary data.
Yeah, I think that's not true. I think that there's confusion about raw versus structured. I mean, structured, I think, has come to mean relational, and Hadoop's fine with relationally structured data. It's also fine with all sorts of other data, which has been lumped together and called unstructured, even though it really should just be called differently structured or not column structured. Right? You can have nested data sets. You can have images. These are all structures of various sorts, and they support different operations than rows and columns. Not all data is rows and columns. But tools like Impala can perform very, very quickly and very efficiently on structured data, on rows and columns. There are tools within the Hadoop ecosystem that perform quite well on that data. There's also a lot of other tools that perform well on what you would have been called unstructured data. So your text, for example, in the search engine, but also if you're doing machine learning, if you're doing log analysis, log data might be, I don't know whether you could call that structured or unstructured. It depends on what you're doing with it. There's a lot of sort of dirty data sets that people, that are generated by devices, and they slight variations in it and that aren't clean, and so you need to do a lot of transformations on it to clean it up, and those are done very effectively in Hadoop, and then you can continue to do analytics in the Hadoop ecosystem. So I think that's a confusion. Sorry, here first.
Yeah. You mentioned Google Spanner and how until people used to think that cross data center transactions weren't really possible until there was this existence proof. Is there anything else like that you see on the horizon, like new capabilities that are going to become possible?
Not that I can think of. I mean, I think transactions were kind of one of these holy grails. I remember reading a report from, I think it was eBay maybe, about the evolution of their data platform through the years, and how they'd re-architected it and rebuilt it 4 different times, and they had it all diagrammed out, and basically they'd learned that you can't do joins across this kind of thing, and you can't do transactions, and you can't do all these things in order to build a scalable system. And they come up with a particular sort of NoSQL architecture for their thing. And that was the sort of, the conventional wisdom was that you simply couldn't do that in a scalable manner. And Google's turned that on their head. They could build a system like what PayPal or eBay was trying to build, I think using Spanner, and actually do that. I can't think of another thing that's like that. I suppose you hear a lot these days about the Lambda architecture, where, I don't know if you're familiar with that, this notion that you use a batch process to build a model, but then you have some updates to your data that are coming in real time, and you want to update the model. So you're using your model to decide which ad to show, or doing some sort of predictive modeling, and you want it to respond to real-time events as well as being based on the vast history that you have. And one way of doing that is this Lambda architecture, where you have that both. You update the model interactively, and then you run batch processes. And I think automating that, making that distinction disappear, Spark streaming kind of gets at that. I'm not sure that that's completely getting at it. Oryx kind of gets at that. But I think that's a big area for how you merge batch and online computation. I think Google's done a lot of work in this area, for example, for their web search engine. I think that, and they've hinted at this at various papers. I don't know if they've published the details of how they're doing it, where they no longer, they're updating in real time all the time the data that you're seeing. And I think within minutes of a site being updated, they can have it in their search engine visible again. And how they're doing that, so that they're clearly doing something that's like big global batch analysis, whether they're doing it all incrementally and updating it, or whether there's some combination of batch and online, and how you can accomplish that without the pain of having the programmer have to think about both of those is the trick that I think I haven't seen solved yet. So that'd be an interesting one to watch. If that wasn't too rambling, made some sense. We're going to take over here.
So what is it like being Hadoop daddy or Lucene daddy, watching ecosystem grow up around something you've created?
Question is, how does it feel to be Lucene Hadoop daddy, to watch these things grow? Partly it doesn't feel real. It's not something that I imagined would happen or at all planned. And I try hard to not take it too seriously, give myself too much credit. I seeded these things by, I was in the right place at the right time and got the right project started. And I was lucky to be there. It wasn't like I aimed and found these spots. It's just, I happened to be that guy. And so I don't want to, I don't think it's right to let that go to my head and so give myself too much credit and spend too much time basking in the glory. Rather, I just mostly try not to focus on that. I live in the country. Everybody who I see on a daily basis has no idea what I do. They know I do something with computers that they don't understand. And now and then they'll see something in the paper about Hadoop, and they're like, "Isn't that crazy thing you did somewhere?" And I'm like, "Yeah, maybe, and I like that, frankly, because it really, it was good fortune that I was able to do that, and 2 times lucky is pretty lucky. Better than being hit by lightning twice. Yeah.
The question is about the integration of Solar into Hadoop. So the Hadoop has inbuilt replication factor, right? So when you index that data and you're creating Lucene segment, right? So the Lucene segment also honors the replication factor. Then how do you have any guidelines about how you plan for sizing of your the deployment? Nodes in it?
So the question is, Solar Cloud has replication in it, and HDFS, which Solar Cloud now runs on, also has replication. And right now, if you use both of them, if you use Solar Cloud replication on top of HDFS, then things are replicated twice, or I don't know how you want to call that, but more than once, which is not the most efficient way to do things. This is sort of one of the tasks that's on the search team's list. It hasn't been a huge priority to try to address it. There's a few ideas of ways to fix that, but so far people haven't complained that it's actually a problem. I think the indexes are not so big that they're using up enough space that people care. The write multiplication of writing the multiple replicas hasn't slowed down the indexing that much, or maybe indexing isn't a bottleneck for folks. For whatever reason, I haven't seen. It was something when we first launched the search product. We'd like, okay, we gotta fix this in the next 6 months in the .1 release. We'll need to fix that, and it's been over a year, 18 months, and there's always more urgent things to work on than that. And I've never heard, maybe you have some experience of using it, of it actually causing problems for folks. I think most people who are deploying search on Hadoop aren't using Solar Cloud's replication. They get sufficient query throughput without each segment of the index, each shard itself replicated. So one machine, one replica per shard is good enough for most folks. If anything, they'll run a second shard just for reliability. So if they lose a shard, they've still got another one that's serving the same section of the index. If they lose a shard server, I don't remember my Solar Cloud terminology right. I don't remember exactly what they call this, but I think you get what I mean. But anyway, it hasn't been a thing that people complain about. It is an inefficiency that might be fixed sometime.
So the Lucene segments are written the same data nodes where CF is written, right? The Lucene segments, are they stored? Will it use the same data?
Well, generally HDFS writes data to the same node where it's the process writing it lives.
Yeah.
And so there's almost always a local copy. If you're shutting down and restarting a search service, then you're not guaranteed that things are initially well located. So you're going to be doing some network I/O at first. But Lucene to operate efficiently ends up caching most of the index in memory anyway. And so the amount of I/O that's happening, the bulk of the I/O basically isn't happening at all. It's happening through memory, and going off machine now and then doesn't seem to hurt performance in the benchmarks we've done. Again, hasn't been a problem. You can imagine trying to schedule where you locate the different solar nodes based on where the local replicas are. I don't think we've bothered to do that at this point. I don't think it's been a problem on startup. Yeah.
So, if you wanted to set up like a fairly small, relatively small Hadoop cluster, right? What would you say some of the big IT operation considerations? I'm thinking things like Zookeeper and mappers, reducers, and all these things that you have to kind of be aware of just to set one up and keep it up.
I mean, if you're the kind of person who builds their own kernels, then you might want to do that. For most folks, I think today they use something like Cloudera Manager, and it does most of that for them. It installs things. It comes up with a default configuration. It has wizards to help you figure out should you be changing the configuration in particular ways, and lets you do that easily without by hand editing files on a bunch of nodes. So I'd say unless you really want to get your fingers dirty, use the higher level tools for that stuff, and then it actually makes it pretty easy. If you select the services you want to run, it figures out what the dependencies are and what needs to get installed and what reasonable allocations of memory and number of map tasks and all those kinds of things just all get done for you.
How about EC2? Does it support it on the EC2 environment?
You can run Cloudera, yeah, you can install Cloudera and run it on EC2. I don't know if Amazon even has machines, or what do they call them, AMIs with it already installed. They might. What's that? They have Elastic MapReduce. They have their version, but I think we have some partnerships with Amazon to. I think you can get. I don't remember the details. Anyway. Yeah.
There's a lot of technologies in the Hadoop space, but for a guy who's just starting out, I heard you mention Spark for your jobs. What would you recommend for scheduling and the SQL-based, ad hoc jobs?
So I think if for somebody first starting, I think it's useful to actually write a MapReduce job, and run that once just so you sort of. I mean, I think of it as like when you learned calculus. They walk you through doing it with these proofs about limits and stuff like that, and then once you learned that, you never did it again. But it kind of gave you some understanding of what was really going on when you're doing derivatives. To have thought about these limits, at least it did for me. And I think similarly, learning MapReduce is sort of a good pedagogical exercise. That said, I think you'd be better off doing most of the stuff in Spark. Spark is a little more complicated conceptually in some ways. Was the other part of your question?
I guess I just kind of meant not necessarily a guy learning, but you're about to deploy your first big data for your enterprise. You can choose from one of 25 different ways to query the data with a SQL-like syntax, and you can choose from a bunch of different ways to schedule those jobs or other jobs for system jobs.
So I mean, the standards there. I mean, Hive is the standard for batch SQL, and I think it will probably remain that. Whether MapReduce stays in its backend or whether Spark becomes its backend. Impala, I think, is the best in class for more interactive SQL. Oozie, it seems to be the standard for scheduling. I mean, a lot of these areas there aren't that many different options. And I think Spark is sort of the only one that really does a good job with in-memory processing. There's a few options for stream processing. The nice thing about Spark is it also does so many other things, and you probably already know it. So you might as well use it for your streaming instead of also deploying something like Storm. You could just use Spark for that too. Similarly, I think if you're doing graph processing, then I would look at the Spark graph library before I'd deploy something like Giraffe. If I had it, and make sure that I couldn't do it with Sparks before I deployed something purpose specific. I try to stick with this small footprint. I think it is actually really important that institutions pick components and pick a stack that they're going to use and encourage all the different applications within the institution at least standardize on that, and also on data formats. Because otherwise you kind of get mayhem if everybody's picking their own tools and they're using different stacks. And it's hard for people to move from project to project, and it gets harder to interoperate, harder to share code, build libraries for one another. Crunch is also a pretty popular API for writing MapReduce jobs. It's a lot simpler than MapReduce, if you've looked at that one. How are we doing?
We still got 30 minutes because.
30 minutes?
Yeah, I mean,
Between us and beer? 30
Yeah.
minutes?
I had one quick question. I guess back in the late 90s, something came out with Java Spaces and Genie and that kind of stuff as a way to distribute computing and the Rio project and that kind of thing, but it never really got any traction like Hadoop has. I mean, what do you think the reason is, or do you ever look at that? Or?
I remember it happening. I didn't look at it too closely. I think it wasn't, it didn't actually, you couldn't download it and do something that you couldn't do before that people wanted to do. So with Hadoop, the initial use case for a lot of folks was log analysis. And they had all these web servers generating all these logs. They knew the information was valuable. They didn't want to pay $1 billion to Oracle to get a database they could put them all in, and then try to figure out how to query it with that. And all of a sudden they had something that they could download for free, take 40 of their old web servers that they'd retired, check all the data on there, and do really interesting analyses of their web logs. And I don't think Genie sort of gave you that out of the box with a 2-page program. You could do that.
Right.
So I think the having the storage system, having the automated reliability, which I don't think Genie, so things were distributed, but they didn't sort of have the storage layer and the automated reliability and this ability to run a computation. So it was that package of functionality which was out of the box, gave people something that they wanted, and solved a problem they had. I think if that makes sense.
Yeah.
There was somebody, yeah.
I was just wondering if you had any favorite resource tools for visualizing data, visualizing what's going on inside of
Zoom data is a pretty popular tool for doing sort of visualizations. That's very Hadoop specific. It's not open source. They're a little startup in the DC area, I think. That does a good job with that. It's really tightly integrated in with both with search and with Impala, and they do a very, very clever job. So you can zoom in and out and scroll and do all these things over really big data sets, and the visualizations update in real time. And they're doing queries that are sampling underneath to keep all the everything bounded, and it's neat stuff. I'd recommend looking at them. I think of others. I already mentioned Tableau is a big player here. Another, they're more traditional. They're doing it all via SQL. Anybody think of others? Those are the two. What's that? Platfora. Platfora is another one. Yes, good one. Those are the ones I know of.
There's data mirror.
Yes, data mirror as well. Yep. Anything else? Yep.
Maybe a ability question. Why are they better in some things than what are y'all doing? What are y'all doing?
Who's competitors?
What are they doing better than you? Why you would go with them instead?
And how are they better? And I'm supposed to answer this, huh?
I said it's a humility question.
So it's an interesting question. So we've got competitors on two sides. We've got other pure play Hadoop companies. So Cloudera was the first out of the gate pure play doing support around Hadoop, and is still far and away the largest. Two others have joined the fray predominantly, Hortonworks and MapR. Hortonworks is probably the second largest, MapR is third. I'd say, Hortonworks might be a quarter to a third our size, MapR a third to a fifth, somewhere in there. So they're both substantially smaller in terms of number of customers, revenue, most metrics. Then on the other side, we've got competitors that we tend to focus more on are Pivotal and IBM and folks like that who are existing huge players in enterprise software who are now saying that they're Hadoop companies. And so we see them in a lot of cases. And those are the companies that, we'd rather gun for somebody big, if that makes sense, and make sure that they're not going to become the standard vendor for this space. It's not a zero-sum game. I expect that many of these folks will continue to exist for quite some time. We don't expect to have a monopoly and be the only Hadoop vendor. Competition is healthy. We try really hard to be the best one. We think it's important that we're independent, that we don't have some other line of business that we're using Hadoop to subsidize on one hand. On the other hand, we think we need to have a good enough business model that we can survive as a standalone company and not get acquired. We want to be a company that when somebody becomes our customer, they can be confident that they'll still be our customer in 10 years and they won't all of a sudden be Oracle's customer because Oracle bought us or something like that. You can't guarantee that, but you'd like to be big enough and solid enough and have a good enough story of how you can be profitable that people are comfortable with that. So we're aiming for an IPO, and I think we're comfortably on that track. I think we're well ahead of our competitors in that grounds of being a long-term viable company. At the same time as staying independent and not trying to push another agenda, which I think IBM and Pivotal and Teradata and companies like that have other agendas. They're trying to sell you something else, and we're not. We're a pure play in that way. So I didn't really give you the why they're better.
Yeah, that's right.
You didn't expect me to.
I never did. You asked the first half. Waiting.
Yeah.
Okay, so it's been 10 years, I guess, since the original Google papers came out. Have you had a chance to really compare open source been able to accelerate to the point where actually like equivalent, is Google starting to use it internally? Do you know anything? Can you share anything about races involved?
The question is Google starting to use Hadoop and some of the open source stuff internally?
How they involved with
I think they're a big company. They've got a lot of really smart, great engineers, and they had a 3-year head start on the open source community at least, and maybe 3 to 5 year. Might be more accurate, or maybe just you could say 5. And I think they've been able to maintain that to a large degree in a lot of areas. That said, I think the open source community probably, I don't know the Google ecosystem intimately, but I expect that we've done a better job of building tools that are independent, that are easier to reuse, that have fewer presuppositions about what the application is going to be, that support a wider range of data types, just because it's a set of independent open source projects, and it's going to be architected differently. My understanding is that Google tends to build things that are pretty well integrated with everything else at Google, which is a strength for them internally, but makes it harder for them for these to become tools that other people can pick and choose among. So I expect them to stay ahead for some time. I don't believe they've adopted Hadoop internally. They now support it at varying degrees within their cloud for customers. But I haven't heard about them using anything from it. They've bought, that said, they bought several companies that use Hadoop. And I haven't heard one way or the other whether they make them switch off and use Google's equivalent internal things or not. For example, they acquired, who are the satellite guys? Skybox. They bought Skybox 6 months ago, and Skybox was a Hadoop shop. Is Skybox still a Hadoop shop? I don't know. Maybe 5-10 years ago, I had friends who had company startups that were bought by Google, and part of the process of being acquired was converting everything to the way Google does things, and basically rewriting almost everything. Whether they do that for Hadoop, I don't know. It'd be interesting to see. Remember when Microsoft bought, golly, I'm so terrible with company names, the folks who were doing the sort of AI system built on HBase, the folks who originally developed a lot of HBase, and they all of a sudden had Hadoop in-house and Java running on Linux, and they didn't move that project off. They kept it alive for quite some time. It may still be alive. So that's not unheard of. That through acquisition, people will do things like that. Yeah.
So Spanner depends on atomic clocks, right? Is there anybody actually developing open source version?
I haven't heard of an open source complete version of Spanner. The dependency on atomic clocks is, as I read the paper, not that hard. They also use GPS devices, which are cheaper, and they only need, I think, 1 atomic clock per data center, and then they have like 2 or 3 GPS devices per data center, and they have all these things, sort of do a quorum. And the only reason they have both is they just decided not to trust one or the other. It's just sort of more redundancy. I don't think it's inherent to the architecture that you couldn't do it all with GPS cards, which are pretty cheap. So somebody could, I think, build it and have it not be. I mean, you would need a data center that was willing to let you put GPS cards in there, which Amazon may not let you do. So that could, at least yet, maybe someday they'll supply that. But I can't believe, given that our phones all have GPS chips in them, that it's that expensive to add that capability. I know there are several efforts to do things that claim to be Spanner-like. I think most of them are proprietary. Many of them are built on Hadoop. I've seen several announcements from companies saying, we've got it today. We've got your fully distributed OLTP system using HDFS or using HBase as the underlying storage substrate. And it's multi-data center and the whole thing. Maybe you've seen these too. I don't think any of them are open source yet. And so, but I think it's a matter of time. I think I've heard of various people working on things like that. The Spanner paper, one of the interesting things I noted about it was that it had, I think, 20-some authors, which is a lot, a very technical paper, which to me implies that it was a really big project and took them a long time to get right. And the next time around, re-implementing it should be easier, but it's still not necessarily easy. Anything else?